This video presentation is brought to you by Red Hat OpenShift, the Kubernetes platform for big ideas.
You're probably either new, interested, or you've been using MongoDB a little bit, and you're looking to kind of take your skills next level, or you're getting into it and you want to figure it out. So anyway, let's jump into this talk and let's see what happens. So first of all, I'm going to just wet your palate a little bit here about why this topic's important and why you should care about it. So I see a lot of databases, particularly MongoDB or document-based databases, and I've seen the #1 most important thing, the most critical part for improving performance and scalability of your database is the schema design of your database. There's literally like it's more important than indexing and caching and doing those other crazy stuff too, because what you're pulling from your database and how it's designed is paramount to performance and scalability. So super, super important. But let's get started here. My name is Joe Karlsson, and I work for a little company called MongoDB. I'm a software engineer and developer advocate. And actually, I live here in Minneapolis, Minnesota. I'm assuming most people are from the Midwest or Minneapolis. And yeah. I've been living here my whole life. So if you want to follow me, though, here's my Twitter, Twitch, TikTok, and my personal website. Best way to reach me if you want to chat about anything software developer related is on my Twitter. And I'm Twitch streaming every week, every Friday at noon on the MongoDB Twitch channel, which is actually just at MongoDB. And then lastly, I don't know if you guys know about TikTok, but I've been making really goofy videos on there recently. There's like 3 of software engineers on TikTok right now, including myself. So if you're interested in that, you should definitely come check that out. Opinions are my own. If I say anything opinionated or whatever, just know it's me and not my company. Please don't get me fired. That would be terrible. And lastly, all the links and resources I discuss in this talk are on that bit.ly link. You can also see that little QR code right in the upper right-hand corner of the page. If you just scan that, that should take you to the page as well. I'll have that QR code wherever you go. I'll have a link to the video, slides, resources, free credits for MongoDB, et cetera, et cetera, et cetera. So let's jump into this. So today, we're going to be talking about a couple things. First of all, I want to do a quick comparison of traditional SQL relational database design and then compare that to MongoDB. I think a lot of people who are in this position are, like most of us come from a relational background. We kind of understand that works, some of the basics of normalization. And I think it's helpful to come from that place to understand how to actually design a schema for MongoDB. Next thing, we're going to be talking about the basic tenets of schema design, which is basically just embedding or referencing. Everything we're doing is a variation on one of these and trying to decide where and how to do this. And lastly, I want to start talking about some typical relationships you see in schema design in general. Again, we're going to be coming from this from a relational perspective and then showing that apples to apples with MongoDB. I'm also going to be showing you some cool hybrid or like advanced schema design use cases at the end to kind of just tickle your imagination a little bit and see what's in store for the future. Okay, so let's jump in. I'm trying to think if there's anything else that's important to know here. I don't think so. Let's start with relational versus MongoDB schema design approaches. So, in my experience, when most developers come to MongoDB and they start designing schemas, their instinct is to just start designing schema designs in MongoDB just like they had done in SQL. They see no difference in it, and they start seeing performance hits almost immediately with these designs. This is bad. My job here is to try to kind of help you unlearn your SQL relational background and learn some new ways, like open your mind up a little bit to new ways of designing a schema for your database. So with relational database schema design, when a developer starts modeling it, you are modeling your data independent of the queries you're going to be making from it most of the time. Most of the time, when you're designing a schema with their traditional SQL database, The developer is asking, what data do I have, and trying to split that up. So let's look at what that looks like. With traditional SQL, there's a long history of like academic studies of normalizing and very prescribed, very rigid approaches to how to structure data, and we do that through normalizing. There's a bunch of different forms of normalizing, and basically normalizing, and it's like most low-level description what it is. It basically is a way to structure data so you're not duplicating data. So for example, if I was designing some sort of user profile page for my documents or for a project, I might have a SQL database that might look like this. I'd have a database with 3 different tables in it, maybe my user table and my professional table and a cars table. And all of these tables would be linked together via foreign keys. So you can see that user ID column in both the professions and cars column, right? So we use that to kind of link all these separate collections together. And that's called normalizing. When you're splitting this data up into, and the reason we're doing this is if we wanted to keep multiple professions and cars per user, we'd have to denormalize the data set, and we'd have repeating data in that user table. So to do this, we're splitting it up, normalizing it, so we don't have to duplicate data. And that's through normalizing. And that's what we're used to. Rows, columns, deduplicating data via normalization. And we can do that to varying degrees. MongoDB schema design is a little bit different. So with MongoDB schema design, you have way more flexibility and freedom to design your schemas based on what you're actually building. There are no rules, there's no prescribed process, and there's no algorithms for designing your schema. There are no rules. The most important thing you can do when you're designing a MongoDB schema is to make sure that you're designing that schema for your application. It's whatever you need. And like, we're gonna be talking about the specifics of what a good schema design for a given application actually looks like. But when you are designing that schema for your application, there's 3 things you want to consider. First of all, you want to consider how you're actually going to be storing that data. So like what that looks like, what's the data structure, what that looks like. The next thing you want to be considering too is your query performance. With anything, there's always a pro and a con. There's always, there's things you have to weigh out. And for your application, you need to make sure you're understanding what that looks like. And lastly, we want to make sure that we're using a reasonable amount of hardware, right? We don't want to like spend $4 billion on 400 replica clusters, right? Like we want to keep things under control too. So we're concerned about the design of that schema, performance for querying and writing that data, and then also making sure that we're not using too much hardware. So let's go back to our original example here of our relational table in a traditional SQL or legacy SQL database. And then I want to show how we would do the same data in a MongoDB database. So let's take a peek at this. That user table, right? We have ID, first name, surname, cell, city, and some geolocation data there. No problem. In MongoDB, if we're going to be translating SQL data, we just take all those columns and we add those as key value pairs in our MongoDB document, right? So we would just translate that over. One note there too, if you check out that location, we're saving that geolocation data as an array of latitude, longitude, basically, right? Geolocation data is a native data type in a MongoDB database. Okay, but we still have those 2 other tables in our traditional SQL database. We have that professions and that car table. How do we save those? Well, with MongoDB, you can just save that as either additional key value pairs, or you can save that as a nested array. And for example, with this professions, since a user can have multiple professions, we want to be saving that as an array of data, right? we just have professions with an array of whatever. And lastly, we have that car data. So this car data is a little bit more complex. You'll see here with professions, we just have a single column, the user ID and the profession. There's not a lot of additional data saved with that. Cars is a little bit different. We have the model and the year. We may even say like make too, right? We could save additional data. And for my design, I might save that as an array of nested objects to save that all together. So if you want to save that all as a single document, that's to be great. So yeah, perfect. And we were talking about too, there's different use cases for when you may separate this out too. But let's do a quick recap here of relational versus MongoDB schema design approaches. So first of all, we talked about was how when you're designing with a relational schema, the thing that most developers or SQL developers are considering is they're modeling their data independent of queries. And usually they're normalizing their data in the third form, or they're just like deduplicating the data by splitting that data into separate tables and then joining those tables based on foreign keys. In this example, we're using user ID. MongoDB schema design is a little bit different though. There are no rules, no process, and no prescribed algorithms. The only thing that matters is what how your application is using that data. And we consider 3 different things: how to save that data, query performance, and make sure that we're using a reasonable amount of hardware. And as I said before, we're designing the schema that works for your application. That's the most important thing here. You make sure that we have to consider your application, how you're using it, and we have to design the schema based around that application. So let's get to the basic tenets of how we're actually going to be doing schema design. And the most important, the bedrock of MongoDB schema design is, are we going to be embedding this, or are we going to be putting this in a separate document or collection, and are we going to be doing referencing to separate objects? So let's talk about what those are and pros and cons of each of them for your application. So first of all, embedding. I think most of us are pretty familiar with embedding. I think one of the advantages of using MongoDB is that we're saving data the way that we're using data in our application. For example, if I'm building a user profile page, this might be the data structure I actually use for when it might actually rendering the front end or saving that on the back end and kind of using that object. This is how we think about that data that we're actually digesting. Right? We're using hash maps, dictionaries, objects, JSON. Right? This is the internet, or this is the data structure of how we as engineers think. But as embedding, we can just embed the data right with it. Right? It's just another key value pair, no problem. And embedding is the same as a join. So remember, we had those separate user tables. We just threw them together, like joining that data together. So if you're considering embedding, why should you be considering that as opposed to referencing, which we'll be talking about in just a moment. So if you're embedding something, one of the key advantages is that you are going to be retrieving all that data with a single query, right? For example, in a legacy SQL database, if you want to get all that data, you have to do a join. And joins are extremely expensive, both time-wise and memory-wise. That's to bring all that data into memory, and that's to execute some functions based on that thing. And that can be, it's a blocking operation, it's expensive, and it takes time. But if you have all that data all at once, so if I'm designing an application and a user profile page, and I need to get all that user profile data every single time someone uploads that user profile page, boom, it's one hit to the database. I get that data, all the data I need, and I don't have to do any joins or lookups or anything. It's super, super fast and a huge advantage over a traditional SQL database. And you could update all that information with a single atomic operation. It's a common misconception that MongoDB is not ACID compliant, which is actually not true at all. First of all, MongoDB by default is atomically, every operation is atomic, like for single operations. And as of 4 or 4.2, you can actually do multiple document ACID operations, even on sharded clusters. So MongoDB can and is ACID compliant. But especially, it's super easy though if you have all that stuff in a single document. boom, instant ACID compliancy, instant atomic operations. Okay, so embedding, a lot of great reasons to it, mostly related to performance. If you can keep all that data together, you're going to be saving a lot of time for your application, and you're not going to be blocking any operations. But when should you be considering not embedding? I think that's the interesting question, right? So, for example, large documents. It's really easy to keep all your data all together, but you should be considering if you don't need all that data all at once, maybe you shouldn't be embedding that. Like if it's pretty rare, you need some data, like I have some user profile information, and maybe I don't use their pet data every single time, like their favorite pet or animal, right? Like, so I don't need, maybe I don't need to embed that in the document, because the larger the document, the more overhead or more data that needs to be transferred over the wire to get that data to you. You want to be keeping your documents as small as possible, but by keeping only the necessary data in it. You want to avoid putting unnecessary amounts of data in it. And it's up to you to decide where that line is. It can be anywhere, right? The other thing to note too is with a MongoDB document, there's a 16 megabyte document size limit per document. I get asked this a lot. It's like, hey, great. I might have some documents that are over 60 megabytes. Okay, cool. That's probably a time for us to reconsider your schema design. If it's over 60 megabytes, there are use cases where that does happen. But for me, that's a code smell or red flag that there's something wrong with your schema design, and we need to be discovering what we can be referencing instead of directly embedding inside that document. So that actually leads me to my next point here, referencing. So with referencing, referencing basically is when you can reference other documents from within a document. So we're embedding just a reference pointer to a separate document in either that collection or a separate collection, MongoDB collection. So I have an example here of my left-handed smoke shifter from Acme Corp, and it might have a lot of different parts. And let's say I'm making a e-commerce store and I'm selling my left-handed smoke shifters, whatever those are. But it's probably pretty rare that I need a complete part list with all that additional metadata information on that every single time I pull up that page, right? I probably just need maybe some basic information, description, name, how many are in stock, the price, and it might be another use case then, like if some rare but case where you need a complete parts list that you can reference and go get that data if and when you need it, but we do not need that every single time in this particular case, right? So that would be a great example of a reference. So referencing, why would we use referencing? Well, first of all, as we discussed, it allows us to break down into smaller documents. It allows us to only deliver exactly what we need while still keeping connections to other data that we might need for other use cases, in our application. This allows us to avoid the 16 megabyte limit imposed by MongoDB documents. And again, if you're hitting that limit, probably red flag, we need to start pulling and referencing some of that data out of your database. And it allows us to not duplicate any of our data. If we can pull that out, we can start doing normalization like we do with a legacy SQL database. I will note though, it's not a problem duplicating data. And actually normalizing data in legacy SQL databases is a super common practice, super common. But this allows us to avoid that if that's a concern, or if we start running into some write performance hits. And allows us to pull out that infrequently accessed data. We gave that example of perhaps I'm not loading up user data or like user favorite animal pets or animal data every single time I load that. Maybe that's an advanced section of our profile page or something. If we're not accessing that data very often, why do we need to be transferring that data over the wire every single time we pull up that page? We probably don't. We probably do not. So let's avoid it. Let's get rid of it. Let's reference it somewhere else. And so we only pull it in if and when we need that for those rare use cases. So add parts of it. Obviously, if you need to get all that data, this requires 2 queries or a lookup operation. And of course, there is a performance hit for having to do additional lookups and queries on lots of documents. There's going to be a hit on it. Can't be avoided, right? It's a pro-con. You need to decide am I saving more time by lowering or shrinking the size of the document? Or is it okay for us to have the slower lookup time for these infrequently used operations or use cases? And that's pretty much it for that. So embedding versus referencing. Those are the total basics of it. Let's do a quick review here. So embedding, obviously, we're just using key value pairs and we can embed data on there. MongoDB, we have super huge flexibility with how we actually want to embed or deeply nest data in there. And embedding is the same as a join with a traditional legacy SQL database. So what are some pros of embedding? Well, we talked about how it allows you to retrieve data all with a single query. All the data is in the object to begin with, done. We don't have to do any joins or lookups, which are slow and expensive. And lastly, we can update all that information in a single atomic operation. Remember, MongoDB can be ACID compliant, and it is with single documents, and it can be with multiple documents too. And things that might go wrong is you might have more overhead going over the wire, which is slower and expensive for network traffic, right? We can't, the more stuff you're sending over the wire, the longer it takes. And lastly, there's a 16 megabyte document size limit per MongoDB document. And let's talk about referencing. So referencing is basically referencing either another document or document in another collection, another MongoDB collection. And we usually reference by a unique ID, just like you would do with a foreign key with a legacy SQL database. So why would you consider using referencing over embedding? Well, when you're referencing, you have smaller documents. You're less likely to hit that 60 megabyte data. You're not deduplicating data. With an asterisk, the duplication of data is not a bad thing. And we don't have to access the data we don't use on every single query. If you're not using it, don't pull it up. That could be a potential performance roadblock for your application. And referencing, why should you not be considering it? Well, referencing basically makes it so that you have to do either a lookup or join in order to retrieve all the data, which there's going to be a performance hit for doing that kind of operation. Okay, cool. So let's see here. This is my favorite part. Let's get into types of relationships. I think it's kind of cool to start digging into specific use cases and compare it to some of the types of relationships we see with legacy SQL databases. So first of all, let's just start with one-to-one. I'm just going to we're going to start easy here, and we're going to ramp up to the some more advanced schema designs. So if you want to be adding one-to-one data to your document, you might have guessed we're just going to be adding key value pairs to our documents, right? This is a user document, and I have one Twitter account, one Twitch account, one TikTok, right? One-to-one, just add a key value pair. All right, pretty easy, right? One user per one attribute you might have. No problem. All right, what about one-to-few? Let's see here. So let's see here. I could have potential multiple addresses. And maybe I have a work address or home address or permanent address or temporary address. You could just do embedded data, either like an array or nested object with additional data for that. Pretty simple, pretty simple. One-to-few, one important note here is that we only have a few addresses. And we're going to be talking about unbounded arrays here in just a second. So I have some general purpose rules here for designing a MongoDB schema. And rule number one is I want you to be favoring embedding unless you have a compelling reason not to. Your default should be to embed it in there, and that should be your default. And I want you, if you ever want to reference it, you should be able to justify why you decide to reference it. I think if you're coming from an SQL mindset, you're just going to start referencing just because that's what you're used to with denormalizing or normalizing data and pulling it into separate tables. And needing to access data on its own is a compelling reason to not embed it, right? So we just need to if we need to get data separately, or we need to get for example, that parts, right? We just need to get that parts data. That is a compelling reason for not embedding it. All right, so we've done one-to-one, one-to-few. Pretty simple so far, not too complicated. Let's get to some more fun ones. So one-to-many. Let's say I'm designing a e-commerce store, and right, we have those. A single product can be made up of multiple parts. We have this bicycle here or whatever, our left-handed smoke shifter we had before, right? These products are made up of many parts, and how do we design an e-commerce store to handle both, like keeping track of all the parts and the products in our database? Well, might design a product, right? We may reference then all of these separate parts on there, because that bicycle or this left-handed smoke shifter may have thousands of subparts that we need to keep track of. So that's a lot. We have one left-handed smoke shifter to 3,000 parts. Keeping all those parts embedded inside that document is a problem, right? That we might hit that, especially if we have all the metadata for that parts that we have in this example. We might run into the danger of hitting that 16 megabyte limit, right? So we can start referencing then at that point. The point is like keeping track of like, what data do we need? So for our product page, are we going to be needing these parts data every single time we load up? Is that a common use case? Or is this a more rare use case that a user might need these parts? And are we willing to separate these out to keep a tight product object, but also keeping that reference all the parts on there? And I think in most e-commerce stores, that is a type of design that would work well for most e-commerce stores. And you'll notice here too, right? We have those foreign keys referencing each other. So we can always reference those in the future with separate lookups and joins. All right, cool. So rule number 3 for designing a great MongoDB scheme design. And see, it looks like I got a question, but I can't view it yet. So I'll get to you in just a second. Rule number 3, I want you to be avoiding joins and lookups if you can, but don't be afraid to if it provides a better scheme design. Right? So we have our example here. Like, we're doing a reference here, but for our imagined e-commerce store, it works well for us. I mean, it's pretty rare, like Amazon, Best Buy, Target, you're very rarely needing all the parts data every single time someone loads up that page. That makes sense for us in this use case, but it's up to you to decide if that's something you're willing to do. And if a reference works great for you, provides a better scheme design, go for it. Do not be afraid to use it. But again, prefer embedding, but if you can justify it and it provides a better scheme design, use a reference. Don't be afraid of them. All right, one-to-squillions. I don't even know if squillions is a word, but I kind of love it. But what is squillions? How is one-to-squillions different than one-to-many? Well, let's imagine we're making a program for logs. And I don't mean like timber logs. I mean, I want to make a program that is able to keep track of server logs. And if you've ever looked at server logs before, or especially like a server farm, you've probably noticed that like log files are completely massive. So imagine with me for a moment that you are designing an event logging system that collects logging messages for an entire fleet of computers or servers. So you have more than one. You're going to have many different servers. Each of them is collecting different log data, and you need to be designing a system to keep track of all that data. How would you do that? So that's squillions, right? Like for many, it's like maybe 10 to a couple thousand, maybe. Squillions is like an unbounded amount of data per machine. That's a lot of data. How are we going to be keeping track of that? So let's actually look at how that works. If I was designing a database schema for that, I might have 2 separate collections, the MongoDB collections. I might have a host that keeps track of all the different computers, and then I might have a separate collection that keeps track of log messages. So this is kind of maybe what I'm thinking here. So you'll notice here, we are going to be doing referencing, but the referencing is different than we had for one-to-many, because you might notice that like our products kept track of all the parts. But in this instance, our host actually keeps track, our host collection keeps track of none of the log data. It knows nothing about it. All it knows about is what it is and kind of where it exists. Maybe it's IP address, maybe some other metadata. But the log messages is where we actually keep all that data. And we're doing a reverse object or ID lookup on there. So you'll notice we're actually keeping track of our host IDs in the log message. So we're referencing it from those message so that we can just keep adding additional messages, start doing queries on those log messages and referencing the hosts that those exist on. We could be keeping all that host metadata in it, but depending on how much metadata is on that host machine, it might be better to keep that in a separate collection. I just want to do, or maybe I have a dashboard that keeps track of just commonly referenced machine data, right? And I only want to be doing some specific queries on the log messages for that dashboard. And this schema design would work phenomenally well. It would work phenomenally well. So again, I just want to show this operation again. With a log message, we're doing a reverse reference as opposed to embedding the reference in the host file. The log message is keeping track of which computer it corresponds to, as opposed to the host keeping track of which log messages relate back to it. This is great for unbounded amounts of data, or one-to-squillions. Because if we kept those embedded, we would guaranteed hit, like 60 megabytes a lot. It's probably pretty rare that we'd hit that with the reference, unless I think it's 40 billion parts. But you're going to hit that eventually, especially if your servers are on for years, right? You're going to hit that. But yeah, both those are referencing up there too. So, okay, cool. One-to-squillions, fun. So, rule number 4 of MongoDB schema design is arrays should grow or should not grow without bound. If you have data that's going to continue to grow without a stopping point, you cannot have that. That's when we do the reverse referencing. If you have a couple hundred maybe, and again, it depends on the data you're using, or like that you're embedding, but maybe a couple hundred, probably okay. Now, a couple thousand, probably you need to be doing some reverse referencing. Okay. All right. What about many-to-many? So imagine with me for a moment, you've been asked to build the hello world of applications, right? The hello, or the to-do list, right? So you are building a to-do list, and in this to-do list, one user can have many tasks, but also one task can have many different users. This is an example of the many-to-many reference. And we have to be able to handle referencing differently than we did before. So I might have a user collection that keeps track of all the users of my application, no problem. And I might have a tasks collection that keeps track of all the tasks for my given application. And we need to make sure that we're referencing those many-to-many relationships together. How would we do that? So this is how I would build this. My person has some metadata about it, but I also would have and like, it depends, right? If we have user, or it may have a couple hundred tasks or whatever. So we're just going to embed those directly, the reference to those tasks inside of that person object. And then you see there on the right-hand side, we have the tasks objects. So we have some metadata about those tasks are, some due date, but you also note there, we also have a owners array that can keep track of multiple owners for that task. So that task, we're doing a reference to that task on the person. We have multiple in there, and we're also have references to the owner on each of the tasks. We're doing a two-way reference in order to keep track of that many-to-many relationship for those two separate documents, or two separate collections. Ooh, fun. All right, so we're getting some fun stuff now. Rule number 5, how you model data depends entirely on your particular application's access patterns. It is, I cannot say this enough, this is the most important data, or most important rule you can think of here, right? When you're designing your MongoDB schema, the most important thing you can do is make sure that you're designing it for the needs of your application. It's not a one-size-fits-all. There's no prescribed approaches. It's how you're going to be accessing that data and what you need from it. That's the most important thing. Okay, so it's here. I want to do a quick recap of this, and then I want to go over some fun little extra hybrid approaches here too. So let's do a quick recap here of the relationships we just covered. So firstly, we covered the one-to-one relationships. No problem, right? We're talking about just using key value pairs. Easy, easy. One to few, we're going to just embed that. We gave an example of that, the embedded, just an array of data in there, right? We're just embedding some data in that. I have a few in there, no problem. We're just going to embed that straight in there. Many to many, that's when we start doing some references. And we gave the example of the product and parts. We may have hundreds to thousands of parts in there. So we're just going to reference those as an embedded array in that object. One-to-squillions, this one I think is so much fun, right? We're doing a reverse reference from the logs. We give the example of building a server logger, right? How would we be building the application out? So we're just going to be reverse referencing those log files to the host information, that host metadata in a separate document. All right, what about many-to-many? That's a two-way reference. So we gave the example of the to-do list, and the user object is keeping track of the tasks, and the tasks is also responsible for keeping references to which owner is responsible for that data. It's a two-way reference of that data to split that up. And let's review those rules, right? So favor embedding. Embedding should be your default option when you're designing a schema. And you should be using embedding unless you can vocalize or explain why you are referencing it. You should have a compelling reason to do it. Needing to access that data on its own is not a compelling. So you can be accessing subdata from the object. So it is not a compelling reason. You want to be avoiding joins and lookups if they can be avoided, and that's by using just embedding that data in there. Array should not grow without bound, right? So that's when we talked about one-to-squillions. If you're having lots and lots of data, you're going to hit that 60 megabyte limit, and that's going to be a potential problem for your application as it grows. And lastly, most importantly, how you model your data depends entirely on how you are actually accessing and using that data. No one-size-fits-all approach. You need to figure out what your application is, how it's using that data, and structure your data depending on how you're actually accessing that data. All right, so let's see here. I got like 8 minutes left. I'm not gonna have time to do all these hybrid approaches. So I just want to cover two of my favorites here. Okay, so I may just do this one here. It's one of my favorites. So imagine with me for a second here that you are building a Twitter-like social media site, right? Just like a social feed here. And we're gonna be using MongoDB as our database. How would we structure that data? So if we had a user object for that, this is, right, we have a typical user, and may keep track of, I have 11,000 followers on Twitter. So maybe, you know, it's hitting the limit, but maybe we'll just keep track of all those followers in there. Like it's inside of that object. Okay. Probably not a great idea, but like we can do it. But what if a Kim Kardashian or like a Justin Bieber joined your site? That is going to be a problem for your MongoDB documents. You're going to hit that limit, right? Kim Kardashian has 64 million followers on Twitter right now. And having an array of 64 million is probably not a great idea. I mean, probably it's pretty rare we need actually all 64 million of those users in a single query. That's probably pretty rare. So how do we handle that? This may be and we use something called the outlier pattern. And there's a ton of these. I'm just going to scratch the surface here due to time. But you'll see here on the bottom, we have for these big power users, it has extras or like an overflow data on it. And that would basically signals to our application that we need to be doing additional work on it. So for example, we are going to start doing some overflows on our application. You see the is overflow equals true, and we're using incremented IDs in order to keep track of the additional followers. So we can reference those separately, pulling that data out and doing some overflows. And this is called the outlier pattern because the Kims and the Justin Biebers are outliers in a system, but we need to make sure we're handling it. And actually, it's interesting that Twitter actually uses a similar outlier pattern for their users. Actually, verified users get handled differently in their system because they're so large, so they need to be handled differently on the back end. This is a very similar approach to actually what they do for real in production. Let's see here. I only have 5 minutes left here, so I'm going to skip it, but I do want to just brag about a project I built recently. This is my IoT kitty litter box. Pretty fun little project. That's me assembling it. But I built a little dashboard that shows my cat's bathroom habits in real time. And I used a time series-based schema design to put that together. I'm just going to show that really quickly. But every day it creates a brand new document. And then in that document, I have an events field. And in there, I'm keeping track. I have an array of every single time my cat goes to the bathroom. It's basically a timestamp and then passive measuring his weight. This is actually what that schema design looks like. Right? So every single day, and I do this because with my dashboards, I have per day, I'm keeping track of how many times he's going to the bathroom. I designed the schema based on how I'm digesting the data on my dashboard. So I can make simple queries onto my database to get the data I need and display that easily on there. My schema design is based on how I'm accessing that data. All right, so I just wanted to touch on some of those because I think they're super cool, but there are a ton of other patterns like those two that I just showed you out there. This is an example of some of them too. There's a great blog post here, which I'll link at the end, with amazing use cases of some super flexible, interesting, innovative new schema designs you can use for your application. All right, let's do a quick recap here and I'll answer the question. So today we talked about relational versus MongoDB schema design. We talked about with relational schema-based or schema design. When developers are designing a schema, they're modeling their data independent of how they're accessing that data. And usually they're doing something like normalizing into the third form. They're splitting that data into rows and columns and doing referencing based on foreign keys. MongoDB schema design is a little bit different. There are no rules, no process, and no algorithms for designing it. You're just designing based on how you're accessing that data for your given application. And some things you want to consider are how you're storing that data and query performance. You're designing that schema for your given application. That's the only thing that matters. And the two basic ways we do that is variations of embedding or referencing. For embedding, it's just a key value pair, embedded data directly in that MongoDB document. And it's the same as doing a join on a legacy SQL database, but it allows us to retrieve all data easily. We don't have any joins, super easy, and it's ACID compliant. But it can get, our documents can get pretty big if we're doing embedding all the time, which is when we do reference. And reference is when we just have a foreign key lookup based on a separate object ID. You have smaller documents, no duplication, and you're not accessing the data you don't need every single time. But 2 queries or more is required to retrieve all that data. And we talked about some of the basic relationships of schema design. We talked about one-to-one. I'm just super easy. One to few, awesome. One to many, where you want to reference the embedded reference ID in the one object. One-to-squillions, we gave the example of a log, the server log application, and you're doing reverse lookups on those applications as they grow to unbounded size. So we need to make sure that we're not going to be hitting that limit as we design those applications. We talked about many-to-many, doing a 2-way reference in order to talk to each other. And then we add 5 rules for MongoDB schema design. So you want to favor embedding unless you have a compelling reason not to embed that data. You also, if you need to access the data on your own, on its own, it is a good reason not to embed it. It's a good reason not to put it in there. If you need to just get that, great. Just throw it in its own thing, not a problem. Avoid joins if you can be avoided, but note arrays should not grow without bound. Super important to know your data, and if you think in the future it will be growing without bounds or adding way more data to it, that's a problem. You want to make sure that you're referencing that instead of embedding that in there. And most importantly, how you model data depends entirely on how you're building it. How you're building it is not going to be the same as another company builds another application, right? You need to figure out how you are going to be accessing that data and making sure you're designing your schema based on your particular needs. Oh my gosh. Okay, let's see here. I'm gonna see here. Check out the Q&A. I got a couple questions here. So Matthew Turland asked, do the embedding, let's see, I'm gonna put this up here actually. He asked, do the embedding and referencing approaches impact query complexity? And they do. So when you're doing like lookups with MongoDB, if you have like super complicated structures or like you're doing like, you're embedding or referencing something that's referencing something that's referencing something, you can do that, but that of course will affect your lookup. You have to design your lookups based on your reference structure of your database. Okay, cool. Let's see here. I don't know what just happened. Let's see here. Brian asked, SQL has column types to ensure the data is valid. Does MongoDB have type system like that? And yes, it does. It is actually another myth that MongoDB is a schemaless database. MongoDB actually has a flexible schema design. And so let me explain what that means. With the SQL legacy SQL database, you're forced to use types for each column. You have no choice about it. And with MongoDB, you can actually enforce types at a database level. You don't need an ORM at all. You can enforce types at the database level for key value pairs or document shape or structure. The difference is you get to choose what is flexible and not flexible. So you have more flexibility. If you want to have a like SQL like super flexible database, you design the schema, no one can do anything else. You can totally do that with MongoDB, but you can have flexibility if an application can have it. So for example, with my IoT litter box, I added a new sensor type and I just updated that schema with that new sensor data, and it wasn't a problem. So for like that kind of application, it's okay to have greater flexibility. But you can have the rigidity if you need it, and that's super important for a lot of massive applications, which I totally understand. Okay, cool. Let's see here. Okay, and then Brian also asked, I love MongoDB, but it's built as a non-relational. We keep showing relational. Yeah, I know, right? I think that just has to do with like, it's not. We don't advertise it as a non-relational database because it is. You can do relations in it. I will say, like, if you're doing relations just because you're used to them with SQL, then that's a problem. But like, we call ourselves a general purpose database, not a non-relational. I think that's like the no SQL thing, but I think it's more what the community calls us, but like isn't entirely accurate to what we actually are. Okay, cool. Let's see here. I think I have one more question here, and then I'll wrap it up. Kevin Boyd asked, if you're just starting out with MongoDB and don't understand the queries you'll need, how do you model your queries and modify your schema as understanding your requirements change? Yes, great question. So things change all the time in applications. The only constant in software engineering is that your requirements will change. Your software will change. It's the only thing that we can be sure of. So I would recommend like you should design your schema based on the needs of what you need in your application, and things will change, and that's okay. And that happens in SQL databases too. We need to add new columns, split things up, reorganize our data, denormalize, normalize data, like super, super common. You can do the same thing in MongoDB. You can just start restructuring, pulling data apart, referencing, running queries, aggregations, lookups based on whatever you need. My thing would just build for what you need, and then you can make changes based on what happens in the future. It's right. We can't predict the future. You can't predict it, but you can adapt to changes as you see them. Okay, let's see here. So I just want to wrap up here, and what's next? So if you're interested in learning more, we actually have a completely free learning system. It's university.mongodb.com. And if you're there's a MongoDB 101 course. If you're brand new to MongoDB, I totally recommend checking it out. But if you want to learn more about schema design, I would check out M320, and that's a data modeling course we have. I'll note here, when I started MongoDB, this is what we use internally to train for internal training for engineers. And it's totally free and open to public. If you're interested in learning it, you need to be checking out university.mongodb.com. It's incredible. And lastly, I'm just going to go ahead and say, if you want to learn this stuff too, or MongoDB in general, just do it. We're sitting at home right now. Like, just go and try to learn some, like on your next application you're building, maybe just try out MongoDB. Throw it as a database on your back end of your next project. See what happens. And if you want to try it out, I can actually give you $100 in free Atlas credits. Atlas is our cloud-hosted MongoDB option, so you don't have to run it locally anymore. It's super amazing. I've never gone over the free tier amount, but just in case, there's $300 on there. And that's with JoeK100. You can use that code when you're signing up to get $100 in free credits. Here's some of the additional references, rules of thumb, documents, and articles I would check out if you're interested in this stuff too. And here's my information one more time. And thank you so much for having me. I appreciate you all so much. You're amazing. And I couldn't do this without your help or you being here today too. So I just appreciate it all. So there's my info. Hit me up on Twitter if you want to talk.